Hello! In this video, we'll be continuing with our discussion on mesh current analysis, but in this video, we will be looking at mesh current analysis with dependent sources. So here, I've described our circuit. It's functionally identical to what we had before, except we've replaced that 6 ohm resistor with a dependent voltage source. And you'll note that since it's referencing to a voltage, that it's going to be a voltage-controlled voltage source. Now I've got the same meshes set up here, so let's start our analysis. I suppose we got to give ourselves a source voltage first. So 12 volts there. Now mesh 1 is going to be our negative 12 volts coming up through the bottom. We go across the 8, I1 minus I3 here. Not I3 minus I1, but I1 minus I3. I1, I3. And then we have Vx, which in this case is 2 I1 minus I2. And this is all equal to 0. Okay, so that's our first mesh. Second mesh, we have up through the 2 ohm resistor, so 2 I2 minus I1, and you'll note this is just equal to negative Vx. Now we have our voltage source come through the negative, so actually what we need to do is subtract it, just as we did for the regular independent voltage source, for Vx. And we come down through the 4 ohm resistor, 4 I2 equals 0. Now for our third mesh. Started the negative terminal of the 8, so we go up through the 8, the positive terminal of the 8, go through the 8, I3 minus I1, across the 10 ohm resistor, and finally back through that dependent source. Now remember, since it's just a voltage, we don't need to change anything about that. That 4Vx, that's going to be a voltage. Now in this case, what is Vx? Well, we already defined it, right? Vx is just the 2 ohm resistor, I1 minus I2. We can sub that in, and voila, we have another set of linear equations that we can use to solve this. So again, voltage sources aren't too much of a big deal with mesh current analysis. And that's really the selling point. If you have a lot of voltage sources, you're going to go for mesh current versus the node voltage, where you might want to prefer that over the mesh current if you had a lot of current sources. Okay, well, let's see how mesh current does with a dependent current source. So I'm going to pause the video, wrap up another circuit here. Alright, so here we have the same circuit, except we swapped out the dependent voltage source with a dependent current source. And again, since it's being controlled by a current, it is a current-controlled current source. So we also know we're going to need a super mesh on this, simply because we have this branch where we're not going to be able to find the voltage just using our normal methods. But let's start off with what we do know. So mesh 1, I think, is just going to be the same. Nothing's changed, so we have negative 12 volts plus I1 minus I3 times that resistance, and finally we come down the 2 ohm resistor, I1 minus I2 equals 0. Alright. Now for meshes 2 and 3. That's going to be trouble, because they're both on that branch with the dependent current source. So we can't actually describe either of those using this method. So last time what we did is we looked at where Ix was and we used that. Well, let's do that again. We've got Ix. It's going to be the current across that 8 ohm resistor. Oh, and we've actually got that in mesh 1. So Ix is just equal to 8 times I1 minus I3. Okay, so that's 2 equations. Now we need a third. We've got 3 unknowns here, right? 3 meshes. Well, that's where the super mesh comes in. So we draw another super mesh all the way around. So in this case, our super mesh will start here at the negative 12, or sorry, at the 12 volt source with a negative 12. Come up and around, go to that 10 ohm resistor. And in this case, we have I3 minus I1. Oh, never mind. What am I thinking? Just I3. Come down the other side, we get to mesh 2. We have 4 ohms times I2, and we're back at the source. So this completes our equation. Now we have 3 equations and 3 unknowns, I1, I2, and I3. And we can solve it now. These are independent equations. So not so much trouble, but we'll take you a bit to redefine that last super mesh. And the important thing to remember is these super meshes cannot impinge upon that branch. So we couldn't, for example, have our super mesh come across like this, because it would just be going across that dependent source, and that wouldn't help us out at all. Alright, that concludes the lesson on dependent sources and mesh current analysis.